Have you ever found yourself staring at a spreadsheet just packed with numbers, feeling a mix of excitement and, just total confusion? Well, if you have, you are in exactly the right place. Today, we're going to solve that puzzle. We're going to turn that data confusion into data clarity by mastering two really basic concepts that'll completely change how you look at data. So let's dive right in.
So, you did all the hard work, right? You ran the survey, you gathered the numbers, and now you're sitting on this mountain of raw data. But here's the million-dollar question. What does it all actually mean? I mean, a pile of data is pretty much useless if you don't know how to make sense of it, or even worse, if it doesn't really reflect the reality you're trying to study. And that, right there, is the core problem we're going to solve today.
Okay, so before we can analyze a single thing, we've got to know what we're working with. Think of it like you're about to start a project around the house. You wouldn't use a hammer to saw a piece of wood, would you? Of course not. You got to sort your tools first. Well, data is exactly the same. We need to understand its level of measurement, which is really just a fancy way of saying we need to sort it into one of three main types.
First up, we've got nominal data. This is the simplest kind, really. It's all about categories or names, hence nominal. Think of things like sex, race, and ethnicity, or religious affiliation. You can put people into these different buckets, but there's no logical order or ranking. One category isn't higher or better than another, they're just different. Next, we climb one step up the ladder to ordinal data. Now, just like nominal data, this is based on categories, but this time there is a logical order. A perfect example is one of those Likert scales on a survey. You've seen them: strongly disagree, disagree, agree, strongly agree. We know for sure that strongly agree is more agreement than just agree, but how much more? We have no idea. The distance between those categories isn't equal. Same thing with your highest educational degree. A master's is definitely higher than a bachelor's, but that distance isn't some fixed measurable unit. And finally, we get to the powerhouse, interval ratio data. This is what most of us think of when we hear the word data. It's truly numerical. It has categories, it has a logical order, and, this is the key, the spacing between the categories is equal and fixed. Think about age in years, or the number of children someone has. The difference between being 25 and 26 is exactly the same as the difference between being 45 and 46. It's 1 year. It's this equal spacing that lets us do all the powerful math we want to do. So here's a quick look at how they all stack up side by side. You can really see the progression, right? Nominal just has categories. Ordinal adds order to those categories. And interval ratio adds that last crucial piece: equal spacing. This little table is a fantastic cheat sheet to keep handy. Figuring out which type of data you're dealing with is always the first critical step. Okay, I get it. That might still feel a little abstract. So let me give you a super simple, really practical trick to tell your data types apart, especially for spotting that all-important interval ratio data. I like to call it the meaningful average test. Now, I know what you might be thinking. When you open your data file in a program like SPSS or Stata, everything just looks like numbers, doesn't it? That's because statistical programs often use numbers as codes, like 1 for male and 2 for female. And this is a huge trap. It's so tempting to just treat them all like real numbers, but that would be a massive mistake. I mean, does it make any sense to add 2 males together to get a female? No way. And this, my friends, is the test. Just ask yourself one simple question. Does the average of this variable make any logical sense? You can absolutely calculate an average age or the average years of education someone has. Those are meaningful numbers. But what about the average sex or the average race? You can't do it. You just get a totally nonsensical number. So here's the bottom line. If you can calculate an average that actually means something in the real world, you are working with interval ratio data. Simple as that. Fantastic. So now we can correctly identify what kind of data we have. But there's another hidden trap we need to talk about. See, knowing what your data is doesn't matter a whole lot if who you collected it from gives you a skewed picture of reality. So let's talk about how to balance your sample using something called survey weights. Let's just imagine we surveyed 2,000 adults. We tried our best to make it a perfectly random sample. But when we look at who actually responded to the survey, we see that 60% are female and only 40% are male. Even with the best intentions, some groups are just more likely to answer surveys than others. So now our sample is skewed. It's overrepresenting women. And here's where we hit a snag. When we compare our sample to the actual U.S. population data from the census, there's a problem. Reality is much closer to a 50-50 split between men and women.
Our sample just doesn't match. And if we analyze our data just like this, our results are going to be biased towards the experiences and opinions of women. We need a way to fix that. And that fix is called a survey weight. A survey weight is this brilliant little correction factor. It mathematically adjusts your data so it better reflects the real population. The best way to think about it is like balancing the scales. It gives a little more influence or weight to the responses from the underrepresented groups, in our case, the men. And at the same time, it slightly reduces the influence of the overrepresented groups, the women. And the calculation itself is surprisingly simple. You just divide the true population proportion by your sample's proportion for each group. So for men, that's 49.2% divided by 40%, which gives us a weight of 1.23. We weight up each man's response. For women, it's 50.8% divided by 60%, which gives us a weight of about 0.85. We weight down each woman's response. Once you apply these weights, your sample's proportions will magically match the populations. It's pretty cool.
All right, so now you know what weights are and why they are so essential. But the big question is, when do you actually use them? This brings us to the single most important, most practical rule you need to remember when you're showing your findings to anyone. Here it is, the golden rule. Seriously, burn this into your memory. When you report your sample size, that's the actual number of people who answered your survey, you turn the weights off. We want the real number of people who participated. But for literally everything else, all your percentages, your averages, your conclusions, you have to turn the weights on to tell the most accurate story possible.
Let's see this in action with some real data from the General Social Survey. With the weights turned off, over on the left, we see the actual count of people who answered. That's our sample size, the N. Now look to the right, with the weights turned on. The frequency numbers look a little weird, right? They have decimals because of the adjustments. But ignore those and focus on what really matters, the percentage. It has changed to 56.1%, giving us a much truer estimate of what the entire U.S. adult population actually thinks. So, by combining these two powerful ideas, first, understanding your data's level of measurement, and second, properly applying survey weights, you move from just staring at a bunch of numbers to confidently telling a truer, more accurate story about the world. These really are the foundational steps to any sound data analysis.
But hey, a quick word of caution here. Weights are really powerful, but they are not magic. All they do is adjust proportions. They don't invent new data out of thin air. If your sample is just wildly skewed, I'm talking, say, 90% female and only 10% male, a weight can't really save it. You still only have the opinions of a tiny number of men to work with. So good data collection from the start is still absolutely essential.
So let's run through our checklist for data clarity one last time. First, always identify your data's level. Is it nominal, ordinal, or interval ratio? Use that simple, meaningful average test to be sure. Then, correct for any response bias by applying survey weights. And always remember the golden rule. Turn weights off for your sample size, but turn them on for all of your results.
At the end of the day, every single data set has a story locked inside it. By understanding what your data actually is, and by making sure it truly reflects reality, you hold the key to unlocking that story and, maybe more importantly, to telling it right.